Welcome to Chapter 9. This is the first section in Chapter 9, 9.1, and we're going to start by finally working with three-dimensional figures, analyzing them, what are their parts, and how are they related to each other. So let's get started. So on the board behind me are some examples of three-dimensional figures. This one represents a sphere, this is a cone, this is a pyramid, and this is a prism, an example of prisms. All right, also I have another example of a pyramid with a different base than this one. And I also have another example of a prism. This one has a different base. So let's look at not so much the cones and the spheres, because those involved curved surfaces. We want to stick with those that involve straight edges, and let's talk about the parts of a three-dimensional figure. So three-dimensional figures that don't have circular surfaces, like these two, all have faces, and they can have different shapes, but they will be a polygon. So a polygon face, the whole surface, is called the face. For instance, in this one here, I have one face on the base, and then each one of these triangles is another face. This one has two triangles on the end, and then three rectangles. Each one of those rectangles is a face. This one here has a square or rectangle base with four triangular faces. This one has all rectangular faces all the way around. So the polygon is the face. The segments that connect those polygons are called edges. So these are this segment here that connects this rectangle with this rectangle, that's an edge. And I have several edges here. All these lines represent edges. We have two types of edges. We have the edges around the base. So for instance, in this one, each one of these is a base edge. And then we have the lateral edges, which are on above the base here. So these are the lateral edges, base edges. So the edges is another part. And then the last part of a three-dimensional figure are the vertices. Each individual vertex is a single point where the edges meet. So this pyramid has a vertex on the top, and then it has each of these around the base. So this one has 1, 2, 3, 4, 5, 6 vertices. This one has 1, 2, 3, 4, 5, 6, 7, 8 vertices. This one has 5 vertices. So we have faces, edges, and vertices. There's a famous mathematician, Euler, and he noticed a relationship between the vertices, the edges, and the faces. And he has this formula in your book. The formula is written this way. If you take the number of vertices, you subtract the number of edges, add the number of faces, you will always get 2. This is an unusual way. This textbook, I learned the same theorem in a different format. I would put e to the other side the way I learned it, and one way I remembered it was to spell the word 5. So if you rearrange this, you get f plus v equals e plus 2. And that's how I learned it, and I spelled the word 5, F-I-V-E plus 2. And so take the faces and the vertices, add them together, and that will be the number of edges plus 2. Both of those work. Notice all I did was add e to both sides to make those two equivalent. But put those in your notes. Understand that's Euler's theorem. It works every time to show the relationship between the number of faces, the number of edges, the number of vertices, and there you go. I put a triangular prism on the board, and I have one in my hand. This triangular prism can be tricky because I talked about whether the edges were base edges or lateral edges. And you may not realize this triangular prism is actually laying on its side. So this is a base edge right here. That's a base edge. How do I know it's a base? Because in prisms, the bases are congruent and parallel. Notice I have two triangles here that are congruent and parallel. They're like a bottom and a lid that match. These sides don't match. They're not parallel. They are all rectangles, that's true, but they're not parallel. They don't form a base with a matching lid. So these are lateral faces even though it's standing on its side. So this is a lateral edge. So be careful of that if you are asked to identify and label them, to know which are the bases and which are the lateral faces. Okay, I've drawn or put on some cones on the board. And what I want to do now is talk about a cross section of a three-dimensional figure. So a cross section is created when I take a three-dimensional object and I just slice it straight through it, like a very thin plane. I tried to draw what I'm trying to represent and it didn't come out too well. But let's say I just have this flat piece of paper and I want to cut through this cone straight across like that. Well, if I can even make it that straight. There you go. What shape would show up on this paper? Or what shape would the top look like? And if it's just straight across like that, the cross section would be a circle. If I took a plane and sliced through a cone again, but this time did it diagonally. For instance, I cut it through sort of like that. Now, what kind of shape would I create? And because it comes through at an angle like this, you would actually create an ellipse. If I took a plane and I just drew a line straight up and down, or sliced through this cone straight up and down like that, and then turned it to see what shape I would have, hopefully you would see that what I would have is a flat triangle. And if I did similar to what I did with the ellipse I went through the cone like this, whoop, like that, at an angle. But what if I cut through through the cone at an angle like that, but it goes through the base like that, then what would it look like? This would look more like that, sort of like a hyperbola with a flat bottom. So those are cross sections. You may be asked to identify what the cross section would be or to draw a cross section, but if you understand it, it's not too terribly hard. So here's an example of a three-dimensional figure. Let's just say that it's a box used to ship large prints. These triangular bases have edges of 6 inches and it is 2 feet long. And you are asked to draw a net representing this figure. So a net is created when we take this box and we just cut it apart. So let's say we cut one end of this and these, and we lay all those 3 lateral rectangular faces flat, and then the base edges at the edge, and add the dimensions. What would it look like? So here's how you would do it. So I used the board to help me so it looks sort of decent. I know a lot of you are great artists. Yours would look really good. But here's my 3 rectangular lateral faces, my 2 triangular ends. Notice I've included the dimensions in my drawing. So now I can clearly see all the faces, the edges, and the vertices of this 3-dimensional figure because I cut it apart and laid it flat and made it a 2-dimensional figure. This is called a net, and this net represents that triangular prism. So why do we use nets, or how are they helpful? Well, here's an example of a problem that you could get. Here is a rectangular prism, just a rectangular box. You are asked to draw a net for this box, this prism, and then use that to find the total surface area. How would you do that? Okay, here's my attempt to draw a net for this rectangular prism and to include the dimensions. Notice I have, here's my top and my bottom, which are 8, those are my bases. They're both 8 by 6, so I have 2 of those. Then I have 2 of the sides, here and here, which would end up being 8 by 2. So actually it's not the sides, it's the front and the back. And then here's my sides here, which is 6 by 2. So I have 2 of each. I have top and the bottom, front and back, and the sides. So I would find the area of each section and then add them all together. These is 48, and so is this, because 6 times 8 is 48. This is 2 times 8, or 16. I have 2 of those. And these are 2 times 6, which is 12. I have 2 of those, and I add up all those together, and I can use that to find the surface area of the entire figure. Okay, let's say you were asked to draw a net for this square pyramid. How would you do it? Pyramids are a little easier. You know that the base is a 4 by 4 square, so start by drawing that square, and then from each side, draw your triangle. So you start with the square and then draw a triangle off of each edge. So I drew this one by freehand so you can see how sloppy they can still be, and that's okay because they still represent the figure and people can tell what it is. What I have not done though is label it. So don't forget to label the dimensions when you draw a net. So these are 4 centimeters. This is 4 centimeters, and these are all 8 centimeters. And probably 1 pair is enough, but it doesn't hurt to be safe to label all of the triangle edges. And there is a completely labeled net of your square pyramid. So that's all I'm going to cover in this video. Don't forget Euler's theorem and what is a face, what's an edge, what's a vertex, and how can I use Euler's theorem to verify how many in all these different figures. Is this a prism? Is it a pyramid? Is it a cone? Those kind of things. And that's it for now. So I will see you guys in the next section.